How does model deployment work?
So basically, there's two higher order categories of model deployments, right? You have your real-time models. So that could be like your recommender system where you go onto your Netflix and you're scrolling and it says, would you like to try something different? And then you say yes, and now they need to hit some endpoint and provide you with a bouquet of new things that you could possibly view, right? That's a real-time or an endpoint kind of model. And then you've got your run-of-the-mill batch jobs that run on set cadence every week, every month, every day. If we consider those two categories, right? So how an endpoint model, right? That goes into a whole realm of its own. So you could have like different models, say A/B testing. So, and there's a nice little thing. It's called, I think, it's multi-arm banded theory. That basically, let's say you've got an endpoint model, right? Or let's say you've got an endpoint use case. I'll use a collective term rather. You've got an endpoint use case for recommender engine, right? And now you've got a bunch of models sitting underneath that, and they'll randomly pick different people, right? Or they'll be applied randomly to different people, and depending on how successful the response rate is for each of these different models, this one might get used a bit more because it's got like an 80% success rate with people actually picking one of those. And so this one will get promoted. And then what's lying underneath all of those models is maybe data scientists, right, who are developing new recommender models. They will then hand it over, for instance, to a machine learning or MLOps person who will then ensure that the data auditing, the feature store auditing, all of that stuff happens, right, and is tracked and checked over time, and alerting is on it. And then there's a promotion process. So once that all gets signed up, maybe they'll then say, okay, cool, well, we've got 10 models that's currently running in production. This one's doing really great, so we're not going to demote that one. We'll demote one of these that's not doing great. Cool, we'll promote this one up. Oops. Then that'll go in, right? Then, depending on that one's performance and tracking, we can see over time, great, okay, cool, this one's doing really well. What's the characteristic there? Data scientists will develop a new one, demote one out, promote one up. So that's on the like live scoring endpoint kind of situation, right? Okay. So that this high cadence, it's normally quite costly because you need to have certain uptimes. You must make sure the infrastructure services these things. They can't go down, for instance, right? Then on the other side of the spectrum is the run-of-the-mill batch kind of jobs that needs to run. So I'll just make an example, it might be easier. So we've got a few models in the fin sector that need to run every month, right? And there's a set population that they look at. They score this population, they provide the score is a propensity for someone to not pay, so to become more delinquent, like I've said earlier, and that's it, right? So it's a model, it needs to run, it needs to just score this population, produce the scores get checked against the baseline from the data scientists, we check tracking, feature distributions, blah, blah, blah.